Yeah, thank you for inviting me, and also thank you very much, Lars, for an interesting presentation. I think, yeah, my talk is about, it has the title More Variation with Inspiration from Forest Ecology and Data on Red Listed Species. So it's actually, to some extent, overlap with what Lars was talking about. It actually covers two different subject areas: forest ecology, as I call it, and data on red listed species. It also, these two fields of knowledge, they are important in our work at the Species Information Center. Forest ecology we are using for defining reference conditions and for boreal forests, and we use that as a basis when we help authorities to set strategic targets for conservation, but also when we assess the conservation status of forest ecosystems under the Habitats Directive. So that's one important part of our environmental assessments that we are working with. But we also work with data on red listed species. We do the red listing of species, but we also work together with forest companies and landowner organizations to develop guidelines for management and conservation based on the information on red listed species and their habitat requirements. So these are two different fields of research and understanding that I think is important to take into account when you discuss how to develop ecoforestry. The forest ecology perspective, it provides a coarse filter perspective on forest ecosystems at large scale. And that's important to take into account. But the data on red listed species can be used as a fine filter perspective to sharpen the management actions that you do in the landscape where you are working, by taking into account what species occur in the landscape and what are the habitats requirements of these species. So my talk is more like a showcase on what kind of environmental assessments that we are working with based on forest ecology and data on red listed species. And hopefully it can be used as an inspiration for this conference. Both these aspects are important. To start, when I talk about forest ecology, I mainly refer to the understanding of boreal forests, disturbance dynamics, and the disturbance regime at large scale, and how it affects the reference conditions. We usually focus, when we work in practice in forest, we usually focus on structures at the local tree and stand scale, but these reference conditions, when we talk about the natural disturbance regime and the structure it results in, it's a large-scale phenomenon. So I will talk about, when I talk about reference condition, it is about this large-scale perspective on it. I will just shortly summarize how the view on reference conditions in boreal forest has changed, and Lars and also Victor already have summarized this, that for a long time there was this old view that boreal forests were quite simple ecosystems, and that they were affected by these intensive fires, and you had this linear deterministic succession starting from more or less bare ground to successively older forests and reaching a climax stage, and then these fires returned and affected the forest's stance again. And by using just simple distribution, probability distribution models, and a return interval on average 50 to 100 years of these fires. They predicted that the reference conditions at large scale were characterized by, you can say, when you look at the stand age distribution of stands, it was mainly a landscape dominated by young and mid-age forest based on this model. And this old view has also been used and is still used to motivate clear cutting, as we have already heard. Timo Kolovainen, he has been important in highlighting the modern research and how the modern research have revised this view on the boreal forests and the reference condition in those. And I think in previous talks here also have described how this modern research have revised the view on boreal forest. I just want to highlight some important findings by research. First, these non-stand replacing disturbances, which are inducing cohort dynamics and fine scale gap dynamics. Research have shown that these types of disturbance dynamics are the really important ones affecting boreal forests. And stand replacing disturbances and the even age dynamics that follows from them, from that kind of disturbances, they occur, but they are far from being as dominant as thought before. So there is a complexity also when you look at the succession of pathways, that they are not as linear as we thought before. You can have a very complex mixture of different disturbances over time that makes these succession of pathways quite diverse, you could say. And this is also reflected in the structure of forest at the large scale. These uneven age forests with lots of very old trees, as Lars described, they were a very important or a key component of these boreal forest landscapes. And so we have these historical studies that Lars described, but we also have studies from reference landscape in northern part of Northern Europe and northwestern Russia, that shows that these types of old forests, they are a dominant feature of boreal forests. And also we have this study by Pennanen modeling natural dynamic boreal forest landscape that show that when we have this kind of mixture of disturbance dynamics, the models predict a landscape dominated by old forests. And basically, if you want to discuss how to mimic these reference conditions, what will be the guidelines, the general guidelines? Of course, it is to, if you want to mimic these less intensive and variable disturbances, you need to use cutting methods that emulate these disturbances. You also need to use longer rotation periods, but also actively work with restoring old forest and their structures. And these photos in the lower part of the slide, it shows these kind of environments that are sort of a result of these non-stand replacing disturbances and the cohort dynamics and gap dynamics from that. So this is this sort of the scientific development and understanding of boreal forest, and Timo Kolovainen, he will talk, I guess, tomorrow more about this and how it can be translated into management. So you get in more detail and depth with him tomorrow. But I want to also tell you a little bit about work I did together with Timo, and we published a paper in AIMView about conceptual models. Conceptual models are important to as an educational tool or a practical tool for both conservation and forest management. And the ACU model, which you probably many of you are familiar with, is one example. It has been really important for increasing the understanding about among forest managers about the importance of natural disturbance dynamics and how you can use the understanding of forest ecology as a basis for developing new methods in forest management. But yeah, you can say that I won't describe the model in detail, but basically the ACU model, it describes how forests along a gradient in site types are affected by forests and how this affects the dynamics and structures of forests. So this diagram at the lower part of the slide here shows that on wet sites you have this forest, the A forests, which are rarely or never affected by forest fires, and they are developing gap dynamics and have that kind of structures that gap dynamic forests have. And that on the other side of this site type gradient, you have these dry poor sites, which are often affected by light, less intensive forest fires. You have these cohort dynamic forest. But the main part of the landscape, these ordinary mesic and rich site types, they are affected according to this model by stand replacing disturbances, and they are shaped by these even-aged dynamics. So by assuming this, that there's a dominance in the landscape of even-aged dynamics, and translating that into management recommendation, where clear-cutting is the method to mimic these even-aged dynamic forests, the landscape become dominated by this kind of clear-cutting management. So it's still sort of have this old view included on this old view on boreal forest, how they work, the reference conditions, and how we should translate it into management. It still remains. So we have suggested how this model could be revised to take into account the modern understanding of boreal forests. And basically, it is the revision is based on the scientific understanding. We have revised the studies on boreal forests, and we have tried to include the fact that these non-stand replacing disturbances are the dominant types of dynamics, gap dynamics and cohort dynamics. And these even-aged dynamics, due to stand replacing disturbances, they occur, but they are not as dominant as previously thought. And also, we also have included a large-scale target for the share of old forests. So this link to the site type is also loosened up, so it's not as strong as in the original ACU model. So when you translate this into management, also it means that we try to mimic these reference conditions with management. So once again, these type of forests, which are shaped by gap dynamics and cohort dynamics, they are important components in the reference condition, reference data, and aim to work against in management. Then The second half of my talk is about how you can find inspiration from an understanding of the species and their habitat requirements. We are now working in different projects together with the users, the managers that manage forests, and what we are trying to do is to make the data that is available useful for managers. The two types of data that we have at the Species Information Center is what we call species facts. It's different, it's classifications of the distribution and habitat and pressures and threats on species. But then we also have these data on where species has been observed. And we can combine these together. Some example of what I call species facts. Here there is a classification of how red-listed species are utilizing different forests, managed forests in different development stages. So we have clear cuts, young forests, and so on. And we, in the end, to the right, we have mature managed forests. We also have to the very right, we have semi-natural or natural forest. This is a classification that has been done, and it shows that most of the red listed species, they are utilizing these old forest in an old managed forest, but also semi-natural forest. So this is just one example of a classification that is done. But if you look at these classification, they also more or less reflect the same as the forest ecology I talked about. That if we want to manage forest in respect to red-listed species, the management should use this kind of less intensive and more variable cutting methods and longer rotation periods and restoring old forest and the structures. These are important habitats for red-listed species. But of course, you can, with the species facts and the species observation, sharpen the management guidelines based on what species that occur in the landscape where you are working. So together with species observation and other information that we have about the distribution of species, we can make local guidelines for managers. So I will just show how it may look like. When we do this, the use of, and the most simple example is that we show where species has been observed on within the land holding of a landowner, and we can give some very simple information about what the species are and what kind of management or considerations it needs to be conserved. But in most land holdings and forest stands, we don't have any information about observation, and then we need to we can develop other types of tools and guidelines based on the pool of species that occurs in the landscape surrounding the landholding. And then it could look like this, that we, based on the information of what species that has been observed in the landscape, we can summarize on what kind of tree species that these species are utilizing or occurring. Like in this pie diagram, giving the example that there are species occurring on or linked to oak, ash, elm, but mainly to beech. And then we can also translate this information into what kind of habitats that more at the tree level and the stand level, what kind of habitat qualities that these species need. We can also develop guidelines at the larger scale, at the regional scale, or we have now a project together with a landowner organization, and the organization is having its own local regions, and we develop guidelines based on the species occurring in these regions, in each of these regions. So, but this slide shows how it may look like at the county level, that we have a county in the northern part and we have another county in the southern part. And of course, the species pools are quite different. But here I have made some pie diagrams illustrating the guidelines on stand level, what kind of actions that need to be done to promote the species in this region. One of the main stand level management actions is to actually set aside and protect stands of trees where the species can find habitat. While in the southern part, it's important to stop the succession and the competition from spruce and other competitive tree species that are sort of growing in and making the forest more closed, because species in this region, they need these sun-exposed and warm habitats and substrates. Yeah. So thank you for listening.